So now we are going to take a look at the use of void pointers in real life, right? Use of void pointers. So first off, the question is, whenever we used pointers that were pointing to a data type, there was information about the size, right? Size in terms of how many bytes should a dereference operation lead to. Now, what I want to do is present a scenario in which there is like memory transfer or data transfer involved, but the size of that memory transfer may not be upfront known to the API implementer, whoever is writing that the API for transferring data. And so what that person can do, what that developer can do is take in void pointers and the size from the user and do the data transfer when that API is called. Now let me set up a situation here, which is like a real life situation, and kind of a best approximation of a real life situation. And we'll go back and explore APIs in the Linux kernel that use the void pointers, right? So let's say the scenario is this: there is a camera, and let me get rid of this, and there is a camera and there is a display, right? So there is a display and there is camera, right? And and then in between there is your machine to which the display and the camera are connected, right? And so let's say that you know transfer of data is from this side through this side. All right, and the specifications now is that the resolution of the screen is like so, and the resolution that the camera gives out, or the image that the camera gives out, is 4K. And let's only talk about an image, like a picture being taken from the camera to be shown on the display. Again, so the 4K resolution generally means that you have about 4 times the information required uh, for 1920 to 1080p resolution. So now what you should understand is, given an image which is of the size 4K, it would need to be condensed. That information needs to be condensed into 1920 by 1080p, to fit into that resolution, the display resolution. Now, not only this, you have developed an application on top of, let's say, Linux. So this machine is like Linux machine, right? So you have developed like a nice app. What it does is it takes an image and puts some nice colorings, enhances the color, some image manipulation, and then displays it here, right? So the flow looks like this. Take an image, right? Modify it, and then third is display it, right? Okay. So this is what you kind of intend to do in your application. You want to fetch an image, modify it, and send it over to the display, right? And let's say there is me right here that you want to, for whatever reason, take a picture of, and then you kind of want to modify things, put some bells and whistles and so on and so forth, whatever. But this is what your app does. Now, few things to be mindful of on Linux is, so for the camera, well, first off, okay, let's not go to the camera. Let's talk about this. So there would be Linux kernel, and only the kernel has access to the display and the camera. So let me then go ahead and kind of modify this diagram a little bit to be like so, right? So only the Linux kernel has access to the actual hardware. And what the Linux kernel does is it has two buffers internally, meaning, you know, think of them as arrays or some memory region reserved for the camera and for the display. The drivers do that, let's say, right? So this is um, um, let's say 10 MB for whatever reason. Let's say this is 40 MB, right? These might not be real numbers, but just for example, these kind of, work. Okay, so whatever the camera image the Linux kernel captures or requests, the data would be available here. And whatever is put into this buffer would be sent out to the display. Let's just make it like that, like for simplicity. Now the question is that your application is running on top of the Linux kernel, right? In something called user level. So the kernel is running in privilege level, and the user space, so to speak, is running in unprivileged level, right? So what unprivileged means is that the application cannot directly go and talk to the camera or the display. So now your application, let's say, has two buffers, 1 MB and 4 MB, or let's make it for simplicity, let's just keep that 10 MB and 40 MB. Let's say you also have that, your application also have that, and in between there is like nice algorithm, right, that you want to run on the image. Now the question is, you are not going to get the image coming from camera directly. So what you need to do, or what your application needs to do, is first off send down a request to the kernel saying, hey, I don't have access to the image. I know where it exists, I know the location of it. Let's say these addresses are open to you, right? Open meaning available to the application somehow. Then you can say, hey, I know the address that you need to copy from, or help me with, but I cannot copy because I'm unprivileged, so I cannot reach out to your memory region. Could you please copy it to a location I ask you to? So there needs to be a request down here, which is called copy to user, right? And we'll take a look at this API, and you give it like the source address and the destination address, and what the kernel will do is it will transfer over data for you. So now your application has gotten the image to work with, and again you requested the kernel to copy over the data, and what the kernel did not know upfront is how many bytes you wanted, right? And let's say that this 4K image happens to be 4 MB. So you'll say, hey, copy to user. The source is, let's say, camera buffer, right? Kernel camera buffer. The destination is user camera buffer, and the size is 4 MB, right? So let's say 4 MB is what this image occupies, and so the kernel will copy 4 MB for you. And this is the user camera buffer, and this is the kernel camera buffer. So what will then happen is, first off, the kernel only wanted you to give it from to, like the destination and the source, and how many bytes to copy. And once you give how many bytes to copy, you know you don't have to specify what kind of data is available there in terms of data types. Is it an int, char, float, whatever, right? So the kernel figures out using the void pointers. So these are provided as void pointers. The kernel will figure out that, hey, okay, it's a 4 MB data. What I can do is I can copy 4 bytes at a time. So it might typecast the void pointer to an int pointer and then run a loop for 1 MB to copy the 4 MB, right? Okay, what I mean is, you want to copy 4 MB. The kernel figures out that, hey, this is a multiple of 4. So what I can do is I can take the void pointer, then typecast it to be an int pointer. And now when I dereference an int pointer, I you know go and hug 4 bytes. And then what the kernel would do is copy 4 bytes at a time from here to here. That's just an example, by the way. The key is that the kernel need not know what kind of data you're pointing to. You just have to give it an address that can be conveyed by a void pointer and tell it the size. And using the source and the destination pointers, the void pointers, and the size, the kernel will do some magic to copy over data from here to here. Now, once the data is available to you, what you do is go ahead and run the algorithm on it and put the modified image, this image in your, let's say, user display buffer. And buffer is nothing but memory location, right? So some sort of a memory, location you have with you somehow, right? Using malloc or something like that, and you have put your image here. Now you want to send another request down to the kernel saying, hey, could you copy from me to your display buffer? And by the way, this is just 1 MB worth of data. So when you copy, can you just fill in the 1 MB correctly so that it's displayed here, right? Or let's say it's 10 MB. You fill all of the 10 MB just to make life easy. Let's say you fill all of the 10 MB somehow using the 4 MB, stretch it, this, that, whatever. Um, your algorithm leads to 10 MB worth of output, all different layers of information, whatever. And so you're now sending out another request saying copy from user to the kernel, right? So copy from user. And it is also similar. It's like, give it the source address, the destination address, just the address, and the size in bytes, the length of the information, so to speak, and the kernel will happily copy it over. So you give it this address, this address, this is the source, this is the destination, this is the destination, this is the source, and you say, hey, copy over 10 MB, and then what it will do is copy over the 10 MB. As a result of this, you will see the modified image on the screen, right? So hopefully the example kind of gives you visualization of the fact that there is memory reads and writes involved here, but the sizes are not upfront known while writing the kernel code, so to speak. The app is the one that is written by you much later, but the kernel needs to account for memory transfers of arbitrary size, and the information relating to that comes in the form of void pointers. And now let's kind of take a look at the APIs. So this link right here will add this link into the description for this video, and this link is for browsing the Linux code online on the bootlin.com website, right? So this is the Linux uh, source code, and in that source code what I did was I searched for copy underscore from user and copy to user. And so if you see what's happening here, the void star 2 is void star 2 is the destination, right? And the void, forget this for now, but star from is the source. So void star from is the source. And then we are also giving it the number of bytes to copy over. And then what it will do is it will check, if the destination buffer has this much size, this, that, and then it will call its own API to run that transaction. Now you can then look for this implementation, the underscore copy from underscore user, and then see the implementation as to how it copies. But our key point here was notice the use of void pointers. Right. Ignore this for now. This has to do with some sort of a type def or some sort of hash define, something like const or something. It will be kind of converted to that. But the key is it is a void pointer, right? And then we look at the example here, which is copy to user. Same story. You have a void pointer here, and then you have a void pointer here, followed by the number of bytes. So hopefully this kind of convinces you that void pointers are important and they are very widely used.